Welcome to Stanford Medcast, the podcast from Stanford CME that brings you the latest insights from the world's leading physicians and scientists. If you're joining us for the first time, be sure to subscribe on Apple Podcasts, Amazon Music, Spotify, or YouTube to stay updated with our newest episodes. I am your host, Dr. Ruth Adibuya. Today, I am joined by Dr. Walter Greenleaf. Dr. Greenleaf is a renowned neuroscientist and digital health innovator based at Stanford University, where he serves as the Research and Innovations Director at the Stanford Medical Mixed Reality Center. With more than 4 decades of experience at the intersection of neuroscience, medical technology, and digital therapeutics, he is widely recognized as a pioneer in applying virtual reality, biosensing, and AI to clinical care. His work focuses on developing tools to support behavioral and physical health challenges, including PTSD, stroke, anxiety, cognitive aging, addiction, and autism. Over the years, he has led or advised numerous groundbreaking ventures, including roles as founding chief science officer at Paratherapeutics and senior leadership at MindMaze and InWorld Solutions, which developed virtual worlds for behavioral health. He currently advises a number of medtech companies and investment firms shaping the future of immersive healthcare. He also supports initiatives like the Virtual Human Interaction Lab and Wearable Electronics Program, and has served as technology advisor to organizations including the NIH, NASA, and the National Science Foundation. Dr. Greenleaf, welcome to the show, and thanks so much for chatting with me today.
I'm excited to be here. I'm looking forward to our conversation.
You have been at the forefront of digital health and neuroscience for over 40 years. Can you take us back to what first drew you to virtual reality in medicine, and how has your mission evolved over time?
I was a graduate student at Stanford working over in the Department of Physiology in the neuroscience program. I was studying how hormones impact our cognitive processes and emotional state and how that changes with aging. I also was very excited about how we can apply technology to improve data collection, data analytics. As part of that, I got to know a wonderfully brilliant person, Jaron Lanier. Jaron started the first commercial virtual reality company back in 1987. I got excited because I saw some applications of VR technology within the medical arena and worked with Jaron to get a license to his technology. I'd started a company when I was in grad school and had sold it in the field of psychophysiological analysis and sleep staging. I had a passion for developing medical products as opposed to publishing papers in journals. I got started because of my relationship with one of the founders of the technology in the field and my interest in moving it into medicine.
I love your origin story and how it is connected to someone that you had met earlier on in your career. I think it's rare to hear about someone who not only witnessed the birth of a new technology, but immediately saw its medical potential. As I looked into your work, it's very clear that you have this passion for translating innovation into real-world clinical tools and how it's shaped the trajectory of your work. You've worked across so many different spheres: academia, medtech, clinical program development. How do you balance those worlds? What has that intersection taught you about translating research into clinical impact?
For me, it's been fortunate that I've been at a place like Stanford University in Silicon Valley. The whole idea of a university is for us to run across other disciplines, other individuals who are passionate about the projects they're doing, have those discussions, and then develop integrated systems that benefit from the hybrid vigor of having a community that shares information and discourse. It's fortunate that being at Stanford University, that there's encouragement to think horizontally as opposed to vertically.
Being rooted in a research environment really does give you that freedom to explore, iterate, stay close to the science while still thinking about application. But of course, to get broader clinical buy-in, perception matters, and many clinicians still associate VR with gaming or entertainment. What's the most compelling way you explain its role in serious clinical care today?
We need to start with the basics of how do virtual environments impact us both cognitively and emotionally, and how can that benefit clinical care? I'm not surprised that people who haven't had a virtual reality experience would assume it's for entertainment or for gaming purposes, but it is a very powerful tool that we can use. I'll go into detail about some of the reasons it's impactful. One of the challenges we have in healthcare is promoting adherence. Often people are prescribed a medication or some process that they need to go through, maybe cognitive behavioral training or exercise or nutrition. Because we don't have the feedback loop or the progress we're making, we often lose the context and we, out of boredom or frustration or lack of appreciating the results, or maybe because we don't see the benefit of the time investment or the economic investment, people stop, even if it's something that could be preserving their life and limbs or their overall health. What's powerful about virtual environments is that we can promote adherence and help people do what they really need to do to be healthy. We can show them the results of sticking to whatever needs to be done. We have a technique where we can, for example, create an avatar of your future self that you could meet in a virtual environment, have a dialogue with your future self that can give you feedback saying, hey, it's really great that you got sleep last night and you've been eating well and exercising well. Look how buff I'm looking 20 years in your future. And look how happy I am. And look at my background, the house I'm in and the car I'm driving. The other technique we have is showing people the context of why they might be needing to do something that might be difficult to do. In this case, we're leveraging what our friends in the gaming industry and the entertainment industry use, which is storytelling. It's with gaming technology and gambling technology. Those fields have learned how to get people to come back, to make things exciting, to make things educational. Sometimes people are competitive and want to be on the leaderboard, or sometimes they want to go through a process to make friends. Using those tools and the context of a virtual environment, we can create a therapeutic process. We can evoke a cognitive state and use that as a challenge or a way of assessing. We can create the context functionally for an emotional reaction to a stimulus. When you're in a virtual environment, you really feel like you're there. A clinician can use the power of exposure therapy therapeutically or the power of reinforced learning to help people do what they need to do to be healthy.
That's such a great way to frame it. Starting with how VR connects to cognition and emotion grounds the technology in the human experience. You're right that until someone actually tries VR, it's easy to underestimate how immersive and persuasive it can be. I really love that example of using avatars and narrative techniques to help patients visualize some of the outcomes and stay engaged. It flips the script on patient adherence and education. One area where that kind of immersive engagement is proving to be impactful is in behavioral and mental health. Can you describe how VR is currently being used to support behavioral and mental health treatment, such as PTSD, anxiety, or chronic pain?
One example of a use case for treating post-traumatic stress is exposure therapy. There's a learned fear reaction that is evolutionarily important. When something is very traumatic for you, you want to avoid it. You've learned to have an anxiety reaction to what might be a common stimulus. You might be driving down the highway and you look over and you see a pile of trash on the side of the road and it triggers a fear reaction because of the time you were in a combat zone. Wherever the trauma came from, you've learned to have a evoked fear response to a stimulus. We can habituate that response. We can teach you the cognitive skills to manage that response if we can give you a controlled exposure to it. A clinician could be asking you to imagine that trauma and try and give you the skills to respond to it, but your brain doesn't want to go there. With a virtual environment, we can gradually expose you to that stimulus. If you're fear of flying, we can have you look over at the dining room table and see tickets for travel there. The next step might be to have you be driving in a taxi to the airport. The next step might be waiting in line to board the plane. During those exposures, we're teaching you how to think about the process and to manage your emotional reaction to it and giving you the skills to do that. Same thing for helping with cravings and addictions. We can put you in a virtual bar scene and have you practice what you're going to say to your friends who are putting peer pressure on you to have another drink. We can make small steps and give you the skills to manage that. You also asked about managing pain. We've had some wonderful validated interventions using RCT trials to demonstrate that by using virtual environment as a way of both distracting you from the pain and then also learning the cognitive skills to manage chronic pain, people can learn to handle that learned fear reaction too. For generalized anxiety disorders, we can give you the tools to see yourself from a third-person perspective, practice how to handle the thing that you're anxious about, give you the skills of how to handle something. We can slow things down, or we can change the context, and you can learn how to manage that fear reaction. VR is very useful for diagnostics too. I love the example of stroke rehabilitation or traumatic brain injury rehabilitation because it does show that here's a process that an individual does need to go through to recover from physical trauma. We can show you the progress dynamically. If you're doing it at home, the clinician can get a status report as to whether we need to change it or discharge you. It's a fantastic example of how being able to both motivate, measure, give feedback, and adjust the protocol precisely for the individual.
Those are really compelling use cases and explanations for how VR can be utilized. When you talk about gradual exposure in a safe, controlled environment and pairing that with skill building, it really highlights the therapeutic potential of VR. It also makes me think of what's happening beneath the surface, what's going on in the brain during these interventions. You've written extensively on this. Could you just walk us through how immersive environments influence brain function in a therapeutic context?
What's great about clinical VR systems is that they create a context of learning and retention. Because we're creating an experience, we also can motivate people by giving some sort of goal that you're shooting for, some sort of feedback depending on what motivates the individual users. What might motivate one person would be competition. What might motivate another person might be exploration and learning. By making the experience pleasant, we're facilitating learning and retention and changing in our nervous system. We shorten the reward feedback loop and we show progress to the individual. We can also provide insight and perspective by changing time and point of view. We create a context, we reinforce the reason to do it, we show why it's important, and we make it fun and engaging.
The idea that VR doesn't just teach information, but creates memorable, emotionally resonant experiences that actually shift how the brain learns and adapts, and being able to compress the feedback loop or shift perspectives really opens up possibilities for deeper insight and sustained change in this space. We know that insight and experience are just part of the picture. We're also thinking about outcomes and evidence. With that in mind, what does the current clinical research say about the effectiveness of VR-based therapy?
We've been doing research on VR therapies for several decades, but it's taken a while because the technology has been evolving, and what might be the state-of-the-art technology 3 years ago is no longer the state of technology. And also previously, the cost made it difficult to do large-scale research. However, now we've had the opportunity to do several large and well-controlled trials to show the efficacies of this approach to both improved assessments and improved interventions. We've been able to show that by using virtual environments to facilitate neurorehabilitation, we can make the progress faster. We can also demonstrate through validated trials that in the long run, we get much better results, more precise results, faster results in the rehabilitation process. The trials that we've done are now significant to show the power and the impact of this technology on different clinical zones. But it's been done with relatively small sample sizes, and we have more to demonstrate. We're now, again, at a new era with a new strata of technology that I think will be able to be demonstrated as being more precise and more robust. But we'll need to expend our research to validate that.
I can appreciate the challenge of trying to think about outcomes, especially when you talk about how dynamic this space is and the idea that the state of the art concept evolves so quickly. But it is encouraging to hear both the pace of research and the real world clinician gains and their convergence. As more clinicians become interested in using these tools, I imagine practical implementation becomes the next big hurdle. So let's talk about that. What are the key considerations when implementing VR into clinical practice? And what advice do you have for early adopters?
There's a lot of amazing academic groups and early stage companies that are pioneering new ways of assessments and new therapeutics in the zone. The challenge is understanding how to bring this into the clinical environment. Clinics are very busy. Clinics can be cost constrained. And new technology won't be adopted unless it's designed to fit seamlessly into the work environment. Considerations such as where do we store the headsets? Who's going to charge them? If we send it home with the patient, how does it send information back to the clinician? Many of those issues are being addressed, but we still have a lot of work to do. We've now shown very adequately the value therapeutically of these technologies to address certain clinical problems. What needs to be demonstrated now is their impact on reducing costs and making things a little bit smoother and easier in the clinic, which will happen, but we have some work to do there.
That's such a grounded perspective. It's so easy to get excited about innovation, but the reality is that even the most promising tech won't succeed unless, as you mentioned, it's built to fit into the day to day realities of clinical practice. This idea of designing for ease and integration is just as important as designing for impact. I heard you say that at Stanford, you are uniquely positioned to shape how these technologies are tested and refined. As Research and Innovations Director at the Stanford Medical Mixed Reality Center, what are some key projects that you're working on that clinicians should keep an eye on?
One thing I'm excited by Dr. Kim Bullock's work over in the Department of Psychiatry. She's using VR clinically to address a number of different behavioral health problems. I'm excited by what's being done over at the Stanford Children's Hospital, where virtual environments are being used to help with stress inoculation, helping somebody be prepared for the experience of coming into the hospital and having a procedure done, and also to distract from uncomfortable procedures, infusions, or even needle punctures in terms of basic research. I'm excited by what's going on at the Stanford Virtual Human Interaction Lab, where Jared B. Balin's group is understanding how VR and AR technology changes our behavior and our attitudes and what can be done to use that both for education and for training. There's a spectrum of work being done at Stanford, and it's exciting to see that. There's also a lot of work being done at other academic centers on the cusp of where clinically the technology is moving beyond the early adopters into the broader healthcare ecosystem, in particular with the use of VR systems for stroke rehabilitation. I think we're seeing some great strides and acceptance there. The other thing I think we should keep our eye on is new ways of doing assessments using virtual reality simulations. We can create a context that evokes an emotional response or a context that challenges our cognitive processes. A head-mounted display is actually a wearable device that collects a lot of information. You can understand eye gaze, facial expressions, voice tone, and movement, body language, the behavioral response, and the emotional response to a stimulus. This gives us ways to objectively measure things that previously before we were measuring subjectively, asking the patient, how did that medication impact you last week? Or how are you feeling now? Hard to do quantitatively. Now we have some environments that we can use in age appropriate and culturally relevant manner to measure how someone reacts to a stimulus. It's powerful for clinical care to do more precise measurements of diagnostic processes and how a patient is doing as they progress in their therapy.
It's quite encouraging to hear how this work is scaling, not just at Stanford, but across academic centers into broader healthcare systems. And the example that you gave of how VR is being used, not only for stroke rehabilitation, but also reimagining how we assess condition and emotional response is truly remarkable. Creating immersive, emotionally relevant contexts while simultaneously capturing psychophysiological data sounds like a level of insight that maybe we've never had before in real time. It feels like we're really moving towards a truly adaptive model of care. Which brings me to my next question. AI, biosensing, and XR are converging rapidly. Can you share examples of how the synergy is enabling personalized treatment or clinical decision making?
We can evaluate someone's progress through, let's use the example of post-traumatic stress that we talked about earlier. We can not only evaluate someone's response to a stimulus by creating that stimulus in a context, we can also measure heart rate variability, respiration, eye gaze to see what they're looking at or avoiding. If we create a context for them to do some exploration or interact with other people, we can see through body language, voice tone, eye gaze, facial expression so much about how they're doing and what is grabbing their attention, and quantify that and use a more precision approach for that individual. And we can also use those same technologies for training. If we're going through trying to learn the three-dimensional representation of the spinal tracts, for example, we can do that in a way because we can measure the individual's attention and cognitive load of the process. We can speed things up or slow them down based on their learnings. I'm excited about the ability to measure the psychomotor movement. Teaching a surgical skill, for example, we can see how somebody is doing that process and give them the feedback how to learn to do that process at their pace on their own time scale and compare how they're doing compared to how they were doing the day before. And not just precision therapeutics, but precision education and training.
That notion really excites me as someone who is in the medical education field. The fact that the same technology can be flipped for clinician training, whether it's learning a new procedure, just reinforces how versatile and scalable the technology is. With all of this rich data comes a new layer of responsibility, especially around privacy, consent, and ethical use. What are some of the most pressing ethical challenges we need to be thinking about?
I'm so glad you brought this up because it is something that we need to get on top of as soon as possible. Because we're able to understand an individual's response to a stimulus, because we can measure how they learn or how they respond to information, and because we're collecting very precious data about someone's emotional state and cognitive state in a quantifiable manner, we need to protect that data. There's a wonderful book that I recommend called The Battle for Your Brain. It goes into detail about some of the concerns that are out there involving the data we're collecting about individual cognitive processes and how that data could be used in a non-clinical context to sell us things or to influence our attitudes and behavior. If we have the misfortune of living in a dictatorship, that same approach and same technology could be used to identify dissidents. It's the type of information that we need to make sure we understand the importance of it and find new ways of protecting it so that it can't be used in an adverse manner.
What I heard from you is an important caution that while the technology holds so much promise, we can't overlook the risks. What you talked about, how data could be used outside of clinical care or even weaponized in the wrong hands, makes it a little bit sobering and underscores the need to build ethical guardrails into the systems from the very beginning. Along those lines, not only does it raise questions about privacy, but also about access. Equity is always a concern with digital health tools. How can we ensure that BR improves healthcare access instead of exacerbating disparities, especially in remote or underserved areas?
One of the things I'm excited about is the potential for virtual environment systems to reduce disparities and be used as a telemedicine platform to reach underserved areas. There's a real thrust right now of conducting distributed clinical trials. In other words, not having people come into an academic medical center, but being able to collect the data in situ wherever they're living and whatever they're doing. Sending a low-cost headset home with a person to help motivate them, to show them their progress, and also to connect people with others and also connect people with their clinician for post-discharge follow-up. One of the things that we should be ready for is a big surge in improvement in the technology when it comes to having it be more multi-user. We're now getting to the point where with pixel streaming and cloud-based rendering that we can have very robust, very photorealistic environments where other people can be there too. We can create an AI system of a clinician who can answer questions for the patient for post-discharge follow-up or before they come in for a session, collect the information that's needed. We can support group therapy and we can also create group experiences for rehabilitation. We now have generative AI to help us customize the environments. We can make sure that they're age appropriate or represent the culture of the individual who's having the experience. We can use this technology both to reach out to underserved populations and use it as a home health hub to both motivate and measure and get feedback. I'm also hoping it can be a way we can conduct research in underserved populations. One example of where things are moving along really well is at the U.S. Veterans Health Administration. They have scaled to every Veterans Health hospital and clinic the use of VR, and they're using it for more than 30 different clinical indications. And the VA healthcare system is in many ways a safety net healthcare network of a lot of people who are struggling with issues such as homelessness or mental health issues are part of that system. With their ability to reach out and cover in a nationwide manner data collection and analytics and provide therapies, I think we'll be able to reach broader than we otherwise would with other technologies.
The fact that we can now deliver highly realistic, immersive environments to underserved communities without the need for expensive infrastructure could really reframe what equitable care looks like in the future. And it sounds like it has the potential to transform not just access, but also outcomes and patient autonomy. So building on that vision and looking 5 to 10 years ahead, what XR or VR applications do you believe will be most transformative in clinical practice?
I'm very worried about the fact that we have an aging population and smaller family sizes, and it'll be hard to provide the informal care support as we get up into our 80s and 90s and beyond. We're going to be living so much longer than previous generations, but we haven't yet really come up with the impactful ways of supporting the health challenges that happen with aging and neurodementia. There's so many issues that we need to make progress on. And I'm excited about the way virtual environments are being used to refine research into the neuroscience and challenges of cognitive aging. I'm hoping that we can use this technology to help empower a new wave of research, come up with new therapeutics to address some of these problems. That's my optimistic hope, that these very powerful technologies can be used to facilitate research and improve clinical care.
That's a deeply important point related to our aging population. And it's encouraging to hear that VR is already helping us better understand and potentially intervene in some of those conditions. But I think it ultimately really speaks to the role immersive technology can play in both prevention and preservation of quality of life. For clinicians who are listening, maybe curious, maybe skeptical, what's one actionable insight or step that they can take to begin engaging with this emerging field?
The first step is, if you haven't had the experience of using today's virtual reality technology, find a way to do that, even if it's borrowing a friend's VR headset and playing a game, or finding a place that is being used clinically. Another way is take a look at the research literature. We now have thousands of papers validating the impact of VR for different clinical conditions. There are summary articles and review articles showing the impact of VR in different clinical zones. Another pathway is to check out, there's several organizations that are assembling people doing research in clinical care in this arena of the International Virtual Reality Health Association. We also have a journal of virtual reality medicine that is worth taking a look at. Cedars-Sinai puts on a yearly meeting called VMed, where clinicians and technologists convene together to look at what's useful and talk about the results. There's many ways to get familiar with it, and many of the early stage companies that are developing these technologies are eager to provide access. If someone is curious, I wouldn't be surprised if it would not be hard to get a loaner system to try out and see how it can be used in your particular clinic or arena.
I appreciate how approachable that advice is. Essentially, try it, borrow a headset, explore the research, and take a look at the incredible work that's already happening in this space. My other takeaway from this conversation is that you don't have to be a technologist to begin to understand how VR can enhance your clinical practice. I think all it takes is being curious and being willing to engage. Dr. Greenleaf, this has been such an insightful conversation. Thank you so much for sharing your expertise with us.
Thank you. It's been my pleasure.
This episode was brought to you by Stanford CME. To claim CME for listening to this episode, click on the Claim CME link below or visit medcast.stanford.edu. Check back for new episodes by subscribing to Stanford Medcast wherever you listen to podcasts.